Hello, everybody out there in math land and science land. Today I'm actually going to make a video about science because I want to go over the benchmark review with you since the science test will be tomorrow, although you have all the way to Sunday to take it, and I would take my time if you can. We are going to be doing this benchmark review as best as we can. I'm going to walk you through it and put the answers down so you know what they are, okay? And explain a little bit about these concepts as I go along. Any change in the speed or direction of an object's motion, that's called acceleration. A measure of an object's change in position during a certain amount of time, that's its speed. A push or a pull, that's a force. The location of an object in relation to another object or place describes its position. The force that acts to pull all objects down to Earth, I call that gravity. An object that is changing its position is in motion. A force that acts against the direction of an object's motion and causes it to slow or stop is friction. And the speed of an object in a particular direction is its velocity. Okay, that's a great page to have with you during the test, by the way. So you might want to keep this for when you're doing the test, okay? All right, now we're going to go through some scenarios here. And I'm going to help you with those answers, okay? Do not worry. All right, cars, bicycles, and people are all objects that can be in motion. What is motion? A motion is a change in the position of something over time in comparisons to a reference point. So that means this. If this is right here, and then you close your eyes, and suddenly you find it over here, that means that there had to be motion because there was a change in the position. It used to be here, and it changed position up here. So that change in position is proof that there was motion because it moved over there, okay? Number 10, acceleration is a measure related to motion. What is acceleration? It's the rate at which that velocity changes, all right? 11, to make sure your measurements are clear, it is important to use appropriate units. Which of this is a unit of speed, okay? So you need to have a measurement of distance, so like a unit of distance over a unit of time. Milliliters are not distance. Grams are not distance or length. Seconds are time first. So here, meters, that's a unit of distance, of length, over time, which are seconds. That's why that's the only one that works, okay? Number 12, be careful with that question. Make sure you're doing it right when you do it on the test, okay? An object moves from point A to point B in 2 minutes at a constant rate. That means at the same speed throughout. What is its speed? Okay, so in 2 minutes. So it went 18 meters in 2 minutes. Okay, 18 meters in 2 minutes. So that's 18 divided by 2. What's 18 divided by 2? That's 9 meters per minute. I know there's 2 9s here, so how come this is not correct? That's because the meters has to be first and the minutes second. Distance first, time second. Distance over time, same here. So this would be time over distance. Distance over time, 9. All right, 13. So sorry, I had to clear my throat. The following line graph shows an object's speed over time. What is happening to the object between points Y and point C? As you can see, it's staying constant right here. It's not changing speed, but the time is changing because the speed is not changing. That means that the object's acceleration is 0 because it is not changing. Only when it changes that speed, that's when acceleration is there. So the object's acceleration is 0. 14, a girl is throwing a ball high into the air and then catching it. What force is responsible for the ball's coming back to the ground? Well, that's pretty easy. That's gravity. 15. A boy is pulling a box by a rope across the ground as shown in the picture, as shown in the figure. What force is working to hold the box down in place? Again, gravity, holding the box down. It's pushing it down. Okay, that's the main difference there. Okay, moving right along. We have a few more questions here. 16. Cars, bicycles, and people are all objects that can be in motion. What is true about motion? That means what's the definition? Well, motion is the change in position of an object. It was here, now it's here, change in position, that means motion happened. Lou and Simone conducted an experiment about speed and velocity. They used 2 toy cars, one red and one blue, and they laid out 2 tracks that were flat and straight. Now they want to change the track for the blue car and repeat the experiment. Here is the data from Lou and Simone's experiment. So, the distance traveled was 10 meters. The time it took it 5 seconds, and it went towards the west. The distance traveled here was 20 meters. It took 10 seconds, and the direction traveled was east. Which change would make the blue car travel at a slower speed? Well, if something's going straight, it's not gonna be slowing down. But if you replace one of those pieces with a curved piece, it's going to slow down at the curve, okay? So it would make it change speed, all right? Over here. The map shows the distances between some cities in Florida. Beth and her family drove from Tallahassee to Orlando. Here's Tallahassee. Here's Orlando. It took the family about 5 hours to get to Orlando. Approximately, what was their average speed in kilometers per hour? So that means they went from there to here, right? So they went 413 kilometers. I'm going to average that out to 400. I'm going to round it, okay? And then it said it took 5 hours to get there, all right? So divided by 5 hours. So now I have to divide this. 5 into 4 can't fit, so I have to go into 40. That's 8 times. 5 times 8 is 40. 0, 5 fits into 0, 0 times. So it looks like it was 80 kilometers per hour. So I got that from the 413. I just rounded to 400, and I divided it by the 5 hours it took them because it's distance over time. That's how you calculate speed. And 400 over 5, that's how I got 80 kilometers per hour. Distance first, time second. Okay, I'm going to talk about these questions. I might not necessarily write them all out, but I am going to talk about them. So let's listen up really quick. Here we go. Lou and Simone conduct another experiment. They lay out 2 tracks that start from a raised platform and then flatten out into a straight flat track. They send a different car down each track. The red car travels at 2 meters per second, and the blue car travels at 2 meters east at 2 meters per second. So one went west, one went east. Lou decides to raise the platform of the blue car's track even higher. Make a claim about how this will change the speed of the car and use evidence to support your claim. If you guys remember the marble coasters, one of my suggestions is if you wanted it to go faster and go through like loops, you needed to start that roller coaster higher on the wall, because that way it would have more speed coming down. So that means that the speed of the car is going to increase when you put it higher, because gravity will pull it down, causing it to speed up. Okay, so when you raise the track, it makes something go faster. The speed increases. Next question. A boy uses a rope to pull a box across the ground. Make a claim about how friction acts on the box and explain your reasoning. So friction against the ground in the box is going to make it slow down, because friction is working in the opposite direction of the motion. So therefore, the friction is going to slow down the motion of the box. That's the same when you press like your brakes on a bike. It's going to make that friction happen against the tire and the ground, so it's going to make you slow down. That's how that's going to work. 21. A truck, a car, and a bicycle are stopped at a light. The light turns green and all three begin to move. The truck uses a big engine for this acceleration, while a car uses a smaller engine. The bicycle rider uses the force of his own muscles, so that's less than an engine. Make a claim about why each vehicle requires different amount of force to accelerate and cite evidence to support your answer. So, how come they need a different amount of force? Well, think about this. You need a big engine for a truck. Why? Because a truck is a big vehicle, and if it's hauling something in its actual bin, in its truck bin, then that means that it needs a lot of force in order to produce that acceleration. So that's why it needs a big engine. Now, a car is smaller than a truck, but it's still a pretty heavy thing. It weighs a couple tons, which is 2,000 to 4,000 pounds. So therefore, you are going to need still an engine, less than a truck, but still a powerful engine in order to move that car. Now, the bicycle is going to need less because a bicycle is way less heavy and has less mass than a truck and a car. It still needs to move, but you can power it with your muscles, okay? So that means a bit bigger force is needed to move something with bigger mass, okay? Suppose each vehicle is pushed forward with a force of the same size. Make a claim about which vehicle will be moving faster after 1 minute. So if you took the truck, if you took the car and you took the bike and you put the same amount of force on them, same amount, which one's going to go further? Well, the bike, because it has less mass. If you try to push a bike with your hand, it might go forward, but if you try to push with that same force against a car and a truck, they're not going to go anywhere. So that gives you an idea. So the lightest object will accelerate the most for that given force. Can an object moving at a constant speed accelerate? Make a claim and then cite it. So if the object is moving in a circle at a constant speed, then it is always changing direction. So even though it's not getting faster, it's still changing direction. And changing direction means there's acceleration. Okay, so the simple answer can be yes, because if the object would be moving, for example, at a circle at a constant speed, even though the speed is constant, it's going to be always changing the direction it's going. Therefore, it is always going to be accelerating. Okay, because for acceleration, there needs to be a change in speed or a change in direction. All right, so I want you to have this video handy and these notes handy with you for when you're taking the test. And you can have your book open, of course, to do the test as best as you can. I suggest doing the test with someone, not just alone, or if you have to do it alone, then maybe don't submit it until someone can take a look at it. You have all the way to Sunday. I'm going to assign it tomorrow, so please take your time, okay? And I hope you watched that Bill Nye video yesterday because it was pretty fun. All right, talk to you later. Bye-bye.